All right, you think you know the story. You think you understand how solar systems work. And then the universe just starts sending you mail from other stars. And things get complicated, fast. So first, you get this message. It's 1I/Oumuamua. It's a ghost. There's no coma, just these weird, featureless red slopes. And it's accelerating in a way that just makes no sense. A complete puzzle.
You jot it down in your notes. Visitor number 1. Let's call it the silent type.
Okay, then the next one arrives. This is 2I/Borisov, and this one is loud. It's blazing with all the cometary gases you'd expect, got some dust. But wait, the chemistry's all wrong. The ratio of carbon monoxide to water? Totally odd. Weird, but a totally different kind of weird.
So that's visitor number 2. We'll call it the gassy one.
And just when you think you're seeing a pattern, it's either silent or it's gassy, bam! You discover 3I/Atlas. The third visitor. And this one is the oldest yet, on this wild hyperbolic orbit, flying backwards against the flow of everything else. This is it. This is the tiebreaker. The third visitor from the stars. The paradox. And that's exactly what we're going to unpack today. All right, Section 1. Visitors from another star. Let's properly meet these cosmic messengers. So what are we even talking about here? An interstellar object or an ISO? It's literally a piece of another solar system that's just passing through ours. You gotta understand, each one is like a priceless message in a bottle sent from a star hundreds or thousands of light years away. It tells us what the building blocks of planets are like out there.
And this really lays out the contrast between those first two messengers. On one hand, you have Oumuamua, which acted like a quiet, rocky, dormant thing. Then on the other, you have Borisov, this loud, gassy, active comet. So one's silent, one's active. It really set up this fundamental question. What is a normal interstellar visitor supposed to even look like?
Now let's get to our main character, 3I/Atlas, and see how this whole thing turns into a genuine cosmic whodunit. Because this is where the story gets really strange. Okay, this number right here. This tells you just how much of an outsider 3I/Atlas really is. An eccentricity of over 6 it's just mind-boggling. Anything over 1 means it's unbound. Our sun's gravity can't capture it. At 6.15, 3I/Atlas isn't just passing through, it is screaming through our solar system on a one-way trip back to deep space. It is absolutely 100% not from around here. So picture this. It's July of 2025. A team of researchers is using the SOAR Telescope and they point it at this new visitor. And they spot a clue. It's got a coma, fuzzy cloud of dust around it. This means it's active, it's shedding material. So, case closed, right? It's a comet, just like Borisov. Nope. Wrong. Here's the paradox. A coma is supposed to be made of gas and dust. The gas, which is just ice turning into vapor, is what pushes the dust off the surface. But when astronomers looked for the chemical fingerprints of that gas, there was nothing. A dusty crime scene with no getaway vehicle. How is that possible?
So, this is the critical question. How do you get a cloud of dust without the gas to push it out? To figure this out, scientists had to become detectives. They had to follow the spectral clues that were hidden in the light bouncing off of 3I/Atlas.
And here are the fingerprints they found. The light coming off it was really red, kind of like some of the most ancient objects way out in our own solar system. It hinted at a surface covered in complex, space-weathered organic gunk. But fingerprint number 3, that was the smoking gun, or I guess the lack of one. Absolutely zero sign of the usual cometary gases. None. And you don't have to take my word for it. The researchers who discovered this, in their own paper, they called it a paradoxical situation. It's activity, but without the engine that's supposed to drive it. It's a comet that's refusing to act like one. So to be sure, the science team checked the alibi. They built a thermal model to see if it was even warm enough for ice to be turning into gas, a process we call sublimation. And the model was crystal clear. Back on July 3rd, when they saw the coma, it was way too far from the sun. It was way too cold. Any water ice would have been frozen solid, buried deep inside. So if it's not melting ice, what in the world is it? Well, scientists came up with a list of alternate suspects.
Maybe the sun's radiation and solar wind are powerful enough to just physically blast the dust off the surface. Or, and this is a really cool idea, maybe 3I Atlas has this super ancient, thick crust that traps most of the gas but lets tiny particles of dust puff out.
Now, solving the mystery of this one weird object, it does something much, much bigger than just closing a single case file. It actually helps us build a bridge between our home, our solar system, and the countless others out there.
And this brings us right back to the beginning. See, Oumuamua taught us silence. Borisov taught us activity. But Atlas, it taught us about the space in between. You realize you didn't just study a single object. You actually built a bridge.
And this is why it all matters so much. 3I Atlas is the oldest interstellar sample we've ever gotten our hands on, and it represents this new third category, a bridge between active and dormant. It shows us that, yeah, the building blocks of planets might be universal, but they can evolve in really strange and diverse ways over billions of years wandering the galaxy. That crusty nature might even help explain Oumuamua's mysterious push.
By teaching us about this bridge state, 3I Atlas has completely changed the game. But it leaves us with one huge, tantalizing question. As our telescopes get better, and we inevitably find more of these visitors, what incredible news stories are already on their way to us from the stars?